Hello children, we will see resistors connected in parallel in a electrical circuit. So look at this activity 11.6 where you can see and refer the figure 11.10. We could see that the resistors used are R1, R2, R3 and you could see that they are connected parallelly, one below the one, and you could see the I which is connecting coming to the point, current is entering the point X and it is getting distributed to the R1, R2, R3. Again current comes out of the point Y. So when I want to connect the potential difference, I connect across the plug point. So now when I connect the resistors in a parallel circuit, I will understand what happens to the current, what is the potential difference and what happens to the resistance. So what I do now, when you look at the circuit, you could see that the current on entering at the point X, from the point X, it gets split, it's getting separated and it is given to R1, R2 and R3. So always in a parallel circuit, current is different. So current changes in a parallel circuit. So what will be the current in R1? So we know that I is equal to V is equal to IR. So we know then I is equal to V by R. So the current here it is going to change. So the total current would be, total current is equal to I1 plus I2 plus I3 because the current is changing. So what about the potential difference? The potential difference V is the same because when you look at the connection, even though the resistors are connected parallel, they finally made it a single unit. You could see the connecting point of the joint plug here. So across which, so they behave like a one unit when I put the voltmeter. So always in a parallel circuit, the voltage remains the same. So then, so how do I find I1? So we know by Ohm's law, in general, we know it is I is equal to V over R. Then I know how to find I1. So I1 will be equal to V over R1. I2 is equal to V over R2. I3 is equal to V over R3. So when I substitute in this equation, the total current is equal to I1 plus I2 plus I3. When I substitute the individual values, so the formula will become, since we are talking about the resistance in a parallel connection, so I put RP in the general way. So my connection would be, so V over RP is equal to V over R1 plus V over R2 plus V over R3. Then V is the common factor. I take V out. When I take V out, 1 by RP is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So V gets cancelled. So my final formula will be 1 by the total resistance is equal to reciprocal of the sum of the reciprocal of the individual resistance. So this is what how I find the resistance in a parallel circuit. You see, the total resistance is equal to the reciprocal of the equivalent resistance of a group of resistance joined in parallel is equal to the sum of the reciprocals of the individual resistance. So if I want to calculate the resistance in a parallel circuit, I have to do the reciprocal of the individual resistance. So in a parallel circuit, what is understanding? In a parallel circuit, current changes, volt V, the potential difference remains the same. And what about the R? Here R in a circuit where the resistors are connected parallelly, R decreases. the resistance decreases. How? Because when I connect the circuits in a parallel way, I increase the cross section area. So in parallel circuit, the cross section area is increased. Cross section area increases. So we know that R is inversely proportional to 1 over A. So therefore, in a parallel circuit, when the resistors are connected parallelly, R decreases. So this is how I find the current, voltage and resistance in a parallel circuit. Now the last on this topic would be, what is the difference between the resistors in series and when we connect the resistors in parallel. Now we will see the difference between the resistors connected in series connection and R in parallel connection. What is the difference? So here we know in series, when we talk about the series, we know the current is same. Current is same. In parallel, current changes, I changes. Then in series, what about the voltage? Voltage changes, V changes. In parallel, V remains the same. Then what about R? In the series circuit, R increases because R is proportional to L. So in a parallel circuit, parallel connection, R decreases because R is inversely proportional to the cross section area. In series, how do I find the resistance? I find the total resistance is equal to, the total resistance series is equal to R1. I just add all the resistance connected in series. So but the same way, how do I find the total resistance in parallel? That will be the reciprocal. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then in practical way, so what happens when I connect the resistors continuously? So suppose this is the main examples. We will see the real life examples. When I want to connect the real life examples, for example, I want to connect a heater, electric heater, and a bulb. So consider here electric heater and the electric bulb, they have the same current, their I is same. Both work on the same current. When I connect them in series, what happens if the bulb is not working? What happens? Since it is a series connection, my electric heater also will not work. So that is the reason when you see the fairy lights, when they look at the fairy lights, when one light becomes the issue, is not glowing, then it becomes difficult for the repair person to identify which light because it's faulty. It is very difficult for them to locate the broken place. So that is what given in this para. If you look at it, you see when the current is constant and when you connect it to your electric bulb and the electric heater you connect in series, what happens? They need currents of, suppose when you keep current constant and if you put them in series, suppose if they are working in different current, then we can't put it in a series connection. Second, one more advantage is when one component fails, then other components also will not work. For example, in fairy lights, when you can see the electrician spending a lot of time in trouble locating, replacing the dead bulb, because each has to be tested to find which has fused or gone. So in series, these are all the disadvantages. What are the disadvantages? One is if the two electrical appliances, they need different current, I can't connect in series. That is, when two appliances need different current, they cannot be connected in series. In series, if one appliance is not working, subsequently the other one will also not work. And also it's very difficult when you connect it in series. It's very difficult in case of fairy lights to locate which bulb is not glowing. Now, because what is the advantage of parallel circuit? A parallel circuit divides the current through the electrical gadgets. So in a parallel circuit, if the two gadgets are working with the same voltage, I can put the different gadgets in different lines. In a parallel way, I can connect it because it divides the current. When the gadget has different resistance and requires different current to operate properly. So if I want to use different appliances with different current needs, so for the same scenario, if I want two appliances which have different current needs, then the solution is I will connect them in parallel. So, and also we know different resistor will show different resistors and they need different current to work properly, provided here V will be same. So this is all about the resistors connected in series and resistors connected in parallel. And you can also follow the video I have posted for the numericals related to resistors in series and resistors in parallel. Thank you for watching. Please do subscribe my channel and like this video. Thank you.